want to welcome you to my lecture today. And this promises to be another exciting topic in statistics. Let me tell you, I actually edited the title of this particular lecture. Was initially, I think I refer to that as a class of logistic regression model, but I changed that title to, I think the more befitting title should be the variant of logistic regression models. Now, let me tell you, as we have variants of a particular disease, like variant of COVID, where you have the Delta, the Omicron, and the like, we also have the variant of logistic regression model. So, which is other forms of logistic regression model. So, I want to welcome you to the new month. I want to welcome you to this topic. In my outline today, I think I'm going to first walk you through how you can actually implement the analysis of categorical variable with R. You know, on Monday, I walk you through the manual way to analyze categorical variables. You know, situation where the response is categorical and the predictor is also categorical. But today, that same example that I walk you through on Monday manually, that I'm going to show you how you're going to run the coding out. Because you know why? Of course, the question will come from analysis of categorical variables in the final. And with a simple code that I'm going to show you now. So from there, after that, I'm going to walk you through, we're going to have review on binary logistic regression. Then the other variant of logistic regression is what we call the ordinal logistic, the multinomial, and the beta regression, which I'm going to walk you through now. Now let's get started. Now you remember on Monday, I walk you through this example, the cervical cancer and age at first pregnancy, where we make use of this table, right? Now I walk you through how to analyze this manually by trying to compute what I call the expected frequencies. And, you know, I walk you through the manual way on Monday, but today I actually want to walk you through how you're going to do the coding in R. Now, when you take a look at this, of course, we're trying to see whether there's a relationship between the age at first pregnancy and the risk of getting cervical cancer. And of course, this is a 2-by-2 situation. You know, we got two levels of, we got two levels of the response variable and the two levels of the categorical. Okay, now if I want to run this in R, okay, all what I just need is 42, 203, 7, and 114. And I wanted to see the order of matter-in-law. You know, you're going to go column wise. You are not going to go row wise. If you want to put that in R, you are not going to say 42, 7. No, you're going to say 42, 203. Then you go back to that again. So I'm going to show you now. Okay, take a look at that. 42. Can you see what I'm observed frequency? I'm going to write less than minus matrix 42, 203, 7, 114. Okay, let me show you. You see that? I follow first 42, 203. I'm trying to go column wise. Okay, now this is 2-by-2. I need to indicate that. Look at that. Numbers of row equal to 2, numbers of column equal to 2. When I actually run that, it's actually going to give me the table, right? You're going to give me the table. And since I'm using chi-square, okay, I told you on Monday that we're going to use a chi-squared. So all you're just going to write chi.test of that, you're going to have your results. Oh my God, within seconds, you have your result. Now, you're going to pay your attention to the p-value. The p-value is already generated. What is your non-hypothesis? What is your alternative? Your non-hypothesis is that there is no relationship between the age at first pregnancy and the risk of getting cancer. The alternative is that there is a relationship. But when you take a look at the p-value now, the p-value here is less than the 0.05 level of significance. And when the p-value is less than a level of significance value, what are you going to do? You're going to reject the non-hypothesis. Rejecting the non-hypothesis here is trying to tell us there's a relationship between the age of first pregnancy and the risk of getting cancer. I'm done. You see, with the software, everything is, the analysis is going to be so easy. Imagine the way we're doing it on Monday. We have to go through the manual way. You know, I deliberately, wanted you to see what happened behind the scene, what the software is actually doing. Okay, with the manual way we actually use on Monday, and with this now, this will enable you to appreciate the software because it was the software we got our result on time. Okay, so that is how you do that. Okay, if you want to code that in now, it's gonna be so easy. If I were you, I also walk you through another example on Monday that I talk about how patients respond to different type of disease, right? You can try to follow this code as well and run it and see what you're going to get. Okay. Okay. So that's all about that. Now, I want to go into the variant now of logistic regression. Let me basically tell you this. We're spending a lot of time on logistic regression because we're in the last unit. Okay. We're in the last unit. And we have different classes of logistic regression. I'm going to tell you now, before I go into the variant of logistic regression, okay, I want us to have a recap on logistic regression. Where do we use logistic regression? We use logistic regression to characterize the relationship between variables when the response variable is categorical. Okay, when the response variable is categorical, okay, that is where we use logistic regression. Of course, when you have two levels, when the response variables have two levels, okay, that is what we call binary logistic. Binary, two levels. Okay, and the two levels that we're talking about, there is no difference between the two levels. For instance, if I'm looking at, if I'm talking about applying for admission into graduate college, it's either you are actually giving admission or not, and the levels there, we don't say there's a difference between them. I mean, when I say different between them, the level is just for coding. Okay, it's just for coding. There's no any meaningful difference. Okay, but situation where the levels, okay, have there's a numerical difference between levels of a response. I'm going to give you an example now. If we run a race, okay, and they pick the first three people, okay, for sprints, somebody is going to win a gold, a silver, and a bronze. Okay, now there's the difference. If the difference between gold and silver is different from the difference between silver and bronze. Now that levels, the situation where levels are ordered, okay, in that situation, it is ordered because gold has more value, followed by what is it called, silver, and followed by bronze. Then you are not going to use logistic regression in that situation. You're going to use the variant of logistic regression that we call ordinal logistic. Ordinal. Okay, now I'm going to walk you, you're going to see the example of the ordinal logistic regression. Now, I said a researcher is interested in what factors influence medalling in Olympic swimming. The response variable in the Olympic swimming is actually going to be categorical. You're actually going to have win a gold or silver or bronze, and you know what? That is ordered. The levels of the response is ordered in that situation. You are not going to use the conventional logistic regression. You're actually going to use a variant. And that is what is happening now. Look at what is happening in the world. You know, when the COVID came and we started seeing situation where COVID now mutates and forming a different form of COVID. We have data now, they're talking about Omicron. And we're going to begin to see whether, you know, the vaccine or whatever that we use for the other version, can it also be used for the other one? The same thing here, you know, you got to identify a situation where, okay, when am I going to use the logistic regression and when am I going to use the variant of logistic regression, depending on the nature of the levels of the categorical response variable. Okay, now, the relevant predictors include the training hours, of course, the diet, the age, and the popularity of swimming in the athlete's home country. Of course, if you take a look at this, there's a distance. There's a distance between gold and silver. The distance between gold and silver is more than the distance between silver and bronze. In this situation now, where the levels of the response variable is ordered, is ranked, then we're actually going to use ordinal logistic regression. It is not going to be the conventional logistic regression. The conventional logistic regression is not going to work. That's what I mean. Okay, another example of the ordinal logistic, you know, a study looked at factors that influence the decision of whether to apply to graduate school. College junior are asked if they are unlikely, somewhat likely, or very likely. If you take a look at the three levels, they are ordered. Okay, they are ordered. Okay, so to apply to graduate school, of course, we're actually going to have some predictors that could determine that, right? Predictors like we are going to put into consideration the parental educational status, because there are some, you know, children, when they see that their parents are educated, they may also want to apply to graduate school. Okay, so whether the undergraduate institution is public or private, or the current GPA, those are the potential predictors. And you know what? The distance, there's going to be the distance between, you know, the 3 points are not equal. What do I mean by? I mean the three levels. The distance between them are not equal. Situation where the distance between levels of categorical variables are not equal, then you're going to use ordinal logistic regression instead of the conventional logistic regression. Okay, now I want to walk you through an example now on the ordinal logistic regression. I'm taking this data set from the University of California at Los Angeles, where they've already collected data set from students, okay, whether they want to apply to graduate school, and of course the response. Some gave, number one student here gave a response, said very likely, and the student that gave a response of very likely, of course, the parent, you know, if you look at the PARED, okay, it's whether the parent has education or not. Okay, when I go back, you know, the parent education has status. Okay, so or not. So that is why you can see the PARED is categorical. And of course, the public that you are seeing here, you know, it is with the nature of the undergraduate school attended by this student, whether it is private or public. And the last one is the GPA. Okay, now in this kind of situation, if you want to model this, you are not going to use logistic or, the conventional logistic regression. What you're actually going to use here is actually going to be ordinal logistic regression. Now, let me quickly chip in this example for in marketing. If a supplier really want to know what influence the satisfaction, okay, of a customers to a product, or call the level of the satisfaction, you're gonna see very satisfied, not satisfied, and stuff like that. Then in that situation, you're also going to use ordinal logistic, because the distance between the levels of the categorical will not be the same. Okay, so I'm just showing 6. We got a lot of data set there. So that is a link if you want to see the whole data set. Okay, so like I told you before, if you want to analyze, we need to start from the descriptive statistics. We're looking at a summary of the GPA here, the GPA of the student. Okay, the minimum, the maximum. Take a look at that. Okay, because that is a major factor to get admission into graduate school. Okay, the other variables are concomitant, the other variables are covariate, because the parent education and the nature of the undergraduate school of the applicant is also the covariate. But the major primary predictor variable here is actually going to be GPA. Is everybody hearing me clearly? Okay, thank you so much. And those of you online, can you also confirm if you're hearing me clearly too? Can somebody confirm? Okay, let me check my chat. Okay, what say? Yeah. Okay, now I'm going to move now. Now, what is the difference between the coding of logistic regression and the ordinal logistic regression? Oh my God, the only difference is going to be POLR. Take a look at the POLR. In the case of logistic regression, it is going to be GLM. Okay, and you are not going to see something that is family equal to binomial. In the case of logistic, in the code, you're actually going to see family equal to binomial, right? But in this one, you are not going to see that. Okay, so that is the POLR. Okay, it's the same code, except that you're actually gonna instead of GLM, you're gonna put POLR. Okay, and when you put POLR, then there's not gonna be family equal to binomial. Okay, of course, there's going to be HESS equal to true, which we call the Asian matrix. Okay, but at the end of the day, oh my God, we got this result. Okay, in the case of when you run ordinal logistic regression, this is what you are actually going to get. You're going to get 2 different kind of results. Okay, and when you take a look, you focus on the coefficient. When you look at the value of the coefficient for the predictors, you see 1.0477, okay, for the parent education, and minus is 0.0588 for whether the person attend public or private. Of course, public is appearing here in the output because the public is coded 1 and the private is coded 0. You know that, right? And then we have the GPA. Okay, you can see the standard error, you can see the t value, and of course we have the AIC, because let's say you are comparing models. Of course, the model with the lowest AIC is going to be the best. Now, I also want to tell you this, because this still belong to the class of logistic regression. The values of the estimate will be called log odd estimate. They will still be called log odd estimate. I want you to take note of that, because we see whether Omicron or Delta or whatever, they are still COVID. Okay, what I'm trying to say here is that whether I'm talking about the binary logistic or the ordinal logistic or whatever, the estimate is going to be log odd. Okay, so then we can get a confidence interval. Okay, we can get a confidence interval for the estimate, if you take a look at what I have here under the value 1.0477, those are point estimate, okay? Because what do I mean by point estimate? When you get a single value, right? Okay, so we can get the confidence, we can get the interval estimates of that, or what we're going to use, since we have said M in our model, we say M less than that, and we do summary M, then we're going to do confidence M. If we want to get, look at that, confidence M, okay, if you want to get a confidence interval for the estimate. And of course, this is a confidence interval for the estimate. Now, how do we interpret? The interpretation will be the same as we have in logistic regression, okay? But when you are interpreting, then make sure you always say log, odd. Now, take a look at my interpretation. Number one, if I want to interpret the parent, if I go back to the table, the parent, PARD, is 1.0477, right? Okay, if I want to interpret that now, I'm actually going to show you how that is interpreted. I said we will say that for a 1 unit increase in that, going from 0 to 1, we expect 1.05 increase in the expected value of apply on the log or scale. As I say, on the log or scale. Okay, the apply is a response variable. I think you know that. So the 1.05 here is actually when I take that one to 2 decimal, the 1.0477 to 2 decimal. So that is the way we're going to interpret each of the coefficient there. Okay, you get what I mean, right? So you're going to do the same for the GPA and for the others. But you are interpreting then why you keep other predictors at constant. I think you know that, right? Okay, so take a look at that. For GPA, we'll say that for 1 unit increase in GPA, okay, we will expect 0.62 increase in the expected value of apply in the log odd scale. We're talking about in the log odd, okay, and I told you we're talking about log odd, okay, why we hold other predictor at constant. Now, if I want to go from the log odd to odd ratio, what do we normally do? Okay, I'm going to exponentiate. Okay, getting the odd ratio from log odd. Okay, I'm going to exponentiate. Take a look at that ESP. Okay, exponentiate. And what I have here now is a odd ratio, not log odd anymore. Okay, odd ratio. In odd ratio, you don't get negative. Okay, so you can see the odd ratio now 2.8511 for parents, 0.9429 for public, and 1.8514 for GPA. That's a odd ratio. That is no longer a log odd. Okay, now how can you actually interpret this? Okay, when you are talking about odd ratio, you're talking about the ratio of two things that are negating, probably the ratio of apply to not applying. You get what I mean? Okay, that's what we mean. Okay, now if I want to interpret, how am I going to interpret 2.8511? Is 0.9429 and 1.8514. I'm going to show you now how we're going to interpret that. Okay, for students whose parent did attend college. Okay, for students whose parent did attend college, or the odds. I'm not talking about log odd anymore. The odds of being more likely. Okay, the odds of being more likely, okay, to apply is 2.85 times, okay, than that of student whose parents did not go to college. Okay, where do I get 2.85? Of course, the 2.85 is from the odd ratio. Take a look at that to 2 decimal. So which means that there is high chance, there's more likely that students whose their parents attend their college, they can also, they will be motivated. The fact that their parents attended college, they will be motivated to also apply for graduate school. You get what I mean? So that is what I was talking about. So we have a way to interpret each of that. Then, and let me tell you this. We can interpret this parental education in 2 ways. Okay. It depends on where I start from. You know, I said for student who parent, you know, did attend college, the odds would be more likely. If I want to start from student whose their parent did not attend college, I'm going to say the odds of that would be less likely. It's just English, okay? More likely for students whose parents attend college and less likely for students whose parents did not attend college, okay? So that is how the interpretation works. Okay, so you're going to do the same thing for school type, but the way we interpret school type is different. Okay, the GPA remain the same, but for the school type, if you take a look, if you want to consider for private school, you remember that in the table, what do you see in the regression table? You saw public, right? If you want to interpret for private school, okay, it's going to be 1 divided by what you saw in the table. What do you saw in the table for under public? It's 0.9429, right? Okay, it's 0.9429, right? The 0.9429 is for public. Automatically, private will be what? 1. And that was why you see here, 1 over that. Oh, give me 1 second. That was why you see here, look at that. For students in private school, the odds of being less likely to apply, okay, is if you take a look at what I have here, 1 over 0.943 is 0.943 is the odd value for public. Automatically for private is going to be 1. So that will be 1 to that. Okay, that is why you have that. And of course, you're going to do the same thing for the GPA. Okay, for the GPA, the 1.85 is coming from the odd. Okay, so I'm going to show you for the GPA now. Okay, you can see 1.8514, right? The odd ratio, right? Okay, so the GPA, so you're actually going to say, because that's another motivating factor to apply to college, to graduate school. For every 1 unit increase in student GPA, the odds of being less likely to apply, okay, is multiply 1.85 times holding or, you know, constant or other variables. Take a look at that. Okay, so that is what we have. Now, the takeaway from here is that before you can run ordinal logistic regression, you have to look at the levels of the response variable. Yeah, at the moment you realize that you know, the distance between the levels of the categorical response variable is not equal, then you're going to apply ordinal logistic. But what of it now? We want to move into another variant of logistic regression model. Oh my God, what is the difference between this and logistic regression that we did before? The logistic regression that we did before, we only consider 2 levels of the response. I'm going to say that again, which we call the binary logistic, the one we did before. You know, the one we did before, you apply, you are giving admission or not, okay, or you get this or not. You know, that is 2 levels. Situation where you have more than 2 levels, and for your information, you have more than 2 levels of the categorical variable, and they are not ordered, because if they are ordered, you will use ordinal logistic. Okay, I'm going to say that again. Situation where you have more than 2 levels of the categorical variable, you know, of the response, categorical response variable, you have more than 2 levels, you are not going to use binary anymore, because the binary means 2. You know, more than 2 is going to be multinomial, and you're actually going to use multinomial when they are more than 2 and they are not ordered. Okay, now I'm going to give you an example now on the multinomial logistic. A biologist may be interested in food choices that alligator make. Adult alligator might have different preferences from young ones. The outcome variable here will be type of food. No food is greater than the other. Okay, type of food. Okay, When you have this food, that food, that food, I'm not gonna say this one is better than this or that. No. Okay. So type of food and the predictor might be the size of alligator and other environmental variable. Another example is this. Entering high school student make program choices among general program. When they are making choices for program, there's general program, there's vocational program, there's academic program. Those are not ordered, okay? But we have more than 2 levels, okay? Now, if I actually want to develop a model that where I'm going to have some predictor variable that will explain the choice of the entry high school student, whether they're going to go for a vocational program or the general program or the academic program. This actually fall under multinomial logistic. You are not going to use other logistic here because no program is better than the other. Okay? What we're trying to say, the distance between the program here is 0. They are all equal. Okay? That's what we mean. Okay. Now, the question now is, how do I run that in R? Okay. How is the code for multinomial logistic regression different from the ordinal logistic regression? Okay, I'm going to use data set again from the University of California, Los Angeles, because they collect data set on that too. And when I do that, they have a data set on 200 students. We're talking about the entry student from high school, right? Where they want to make choice of the program they want to go for, right? Now, the outcome variable is prog, which we call the program type, right? Okay. Then the predictor variable are socioeconomic status and a 3-level categorical variable. I mean, the socioeconomic status is a 3-level categorical variable and a writing score. And let me tell you this. If you want to run multinomial, okay, in R, multinomial logistic regression in R, oh my God, take a look at what I have here right now. I'm 4 of us write the program. I'm going to write R level. And since I have 3 types of program here, I need to make one to be referenced. You remember the other time where we have 2 levels, we normally code it 0 and 1, right? But now we have 3 levels. How do we code that? So out of the 3 levels, out of the 3 groups, I need to make one reference. And the one I'm going to make, you can decide to make any one reference. Here, I'm trying to say I'm making academic reference. Don't forget, there is academic, there is general program, there is vocation, right? You got to decide on the one you can make a reference. Then after that, I'm going to go into the code. Oh my God, in the code, look at multinom. Look at that. Look at it in the code. Multinom. In the case of ordinal logistic, it was polyhar. In the case of the conventional logistic, it was a GLM. Okay, take a look at this multinom, the program, okay, on SES, like that. Get what I mean now? So then I'm going to get a result. This is the result that will come out. This is the result that come out. And I wanted to pay attention to this result. In this result, you can only see general and vocation. There is no academic because the academic is being referenced. Take a look at that. General, vocation, no academic, because I've already referenced academic. Okay. Now I have this result. Now, how is the model going to look like? I want you to pay attention to this now, because the way the model is going to look like is different from what we have been doing. Now, I'm going to show you how the fitted model is going to look like. It's going to be log. Okay, I told you anything from logistic regression and the variant of logistic regression is still going to be log odd, right? Now it's going to be I'm going to have 2 models. Why am I having 2 models? The first model will look at the, a particular program, okay, general program with the respect to what you reference. What do you reference? You reference academic. And another model, we look at a vocation with respect to academic as well. Take a look at the two models. I'm looking at that with respect to the academic because academic was reference. If you reference a different program type, okay, it's also going to be with respect to that. That's what I mean. Look at that now. Okay, and that will be equal to, we're going to have the intercept, the slope, and the SES 1 and SES 2. Why do I have SES 1 and SES 2? And I'm going to tell you now, because we have three categories. We are told here we have the SES is socio-economic status, and they are three in number. If there are three in number, of course, what you're going to see in the model is going to be two, because one of the socio-economic variable will be referenced as well. Okay, so that is a model. So this is a model now. Okay, and you know what? What we're going to put in each model is already here. You actually come back to the estimate. Look at that. So what you're going to put in them is already here. So take a look at what we have. Okay, now, if you look at part of the model is 0.058, where does that one come from? It's 0.058 is actually from, if you want to talk about right, general, do you see right? Minus is 0.05793. Okay, if I want to look at, that one is for general, right? Then minus is 0.11360. If I want to look at whether right score is significant to any of that. So if I want to interpret that, okay, what I'm going to say, I'm going to say a 1 unit increase in the variable right is associated with a decrease, okay, in the log hard. Oh my God, log hard. Okay, log hard of being in general program versus academic program. Why do I say general program? I'm going to tell you now. The minus is 0.05793 is correspond to general. Okay, whatever you want to say about general will actually be in relation to what you reference. What do you reference? You reference academic. Okay, the decrease is because of the negative. Take a look at that. Okay, so I'm interpreting that now. And of course, I'm still on the right, but this time around, on vocation. What is the value? Minus is 0.11360 for vocation. So what I'm going to do now, okay, the interpretation is basically going to be a 1 unit increase in the variable right is associated with a decrease in the log out of being a vocation program versus academic program. Okay, in the amount of that. You can see I was making reference to what with the program type that I made reference, which is academic program. You get what I mean, right? So I think I put everything, and the one of 1.163. Let me go back and show you 1.163. Okay, now when you take a look at what I have here, 1.164, you can see under the if you take a look at the second form of that, if you look at the SESI for general is minus 1.1628, and what SE, if you take a look at, we have a two SES here for middle for I. It means what they reference is SES low. We have 3 levels of what? We got 3 levels of socioeconomic class. And of course, it's only 2 that will be reported because of the categorical. So take a look at that. If I want to explain the one for I, okay, the contribution of I to the general, okay, basically, this is what I'm going to say. The log odd of being in general program versus the academic program will decrease by 1.163 if moving from low to SESI. Moving from low to SESI, the low SES, the low socioeconomic class is being referenced. We're talking about movement from what is a reference. What do we reference? We reference the SES law, and that is the reason why the SES law is not reported, because it is reference. Okay, so when you are interpreting, it has to be a movement from that SES law to that. Okay, that's why you have that, because what also determines the choice of program may be movement, because we move all the time. Okay, we move all the time. Okay, so that is what that means. Okay, so I put the other interpretation for middle, for whatever is there. Okay, and at the same time, we can also find the odd ratio, just like what we did before. Okay, and that is then we can also have predicted probability. If we want to predict what is the probability that they actually going to, if you take a look at this, okay, we have low, middle, and high, and we also have the right. Those are the two predictor variables. If I have information about them, can we have a way to make a prediction for those that will have the choice of going for academic, going for general, or going for vacation, or for vocation program? I want to tell you, with the information provided, we can do that. And that is how we have this. Now, finally today, beta regression model. When do we use beta regression model? We use beta regression model in a situation where the response variable is proportion or rate. The response variable is no longer categorical. You know what I mean by categorical, but this time around, it is a rate. What do I mean by rate? Something that lies between 0 and 1. It is not 0, it is not 1, but it lies between 0 and 1. Okay? So, situation where you actually want to model, you want to look at the effect of some predictors on proportion. For instance, you can look at fascination rates. I want to say fascination rate can never be 0% in a country where, they of course, at least they're going to vaccinate one person. Okay. So, and I want to believe 100% may not be vaccinated. So that is so you're going to go from, you're going to be greater than 0, but less than 1. Okay. So they will use beta regression model when the response variable is not categorical, but is a rate. But a lot of people, some researchers normally make mistake. By some of them normally apply logistic regression for that, and that is not going to give you a good result, because logistic regression is only being applied for categories. Categories is different from proportions. It's different from rate. Okay. And that was why I said the gasoline yield data proportion of crude oil converted to gasoline after distillation and fractionation. And what about the proportion of individual infected with SYZ when exposed to the levels of artificial preservative agent? Okay, so well, let me tell you this. If you want to do this in R, you need to load a package called beta reg. This is new. Okay, this is very new. Okay, beta reg. Okay, now the gasoline, with that you're going to have access to a data set called gasoline yield, and you're going to yield on, you are looking at the effect of batch temperature on that, but yield is not categorical. Yield is a rate of proportions. Okay, so by the time you write the summary of that at the end of the day, you're actually going to have your result. Look at that. This is it. But what is the code? You can see the code here. It's beta reg. Did you say beta reg? Okay, beta reg. You see beta reg, right? So this is what we use when your response variable is a rate or proportions. We use beta regression. We don't use logistic regression. Okay, like I said, this is very new. For those of you in economics, engineering, and so on, you talk about rate or proportions. Okay, where it is, rate and proportions are not categorical. Okay, we use a beta regression model, and that is going to be the end of logistic regression in general. When next we're actually going to meet is going to be on Poisson regression model. But let me prepare your mind before we go. For Poisson regression model, the response variable is going to be